In this video, we're going to have a look at volume of rectangular prisms. Volume of a three-dimensional object is the amount of space it takes up. It's measured in cubic units, such as millimeters cubed, centimeters cubed, meters cubed. Capacity, on the other hand, is the amount a container can hold. It's commonly measured in milliliters or liters. A prism is a three-dimensional shape which has the same cross-section throughout its height. For example, for a rectangular prism, no matter where we cut it through the shape, it's still a rectangle. A triangular prism, no matter where we cut it along its length, it will still be an identical triangle. Let's take this rectangular prism. Let's say that the base of the prism has a layer of 4 blocks and 2 rows of that. That is, the area of the base would be 4 times 2. And we have 3 layers of that in the height. That is, the total number of blocks would be 4 times 2 times 3. This, in fact, gives the volume. That is, 4 times 2 is 8, times 3 is 24, assuming these are centimeters cubed. It doesn't matter which way the length, which one's the width and which one's the height, because we can turn the object around and the volume wouldn't change. So let's just say the length, L for length, the width, W for width, and the height, H. Let's do this one as an example. So the volume is therefore the length times the width times the height. Instead of writing that out, we can use the formula length times width times height, or you may even see it just as LWH. In this case, we'll say that the length is 10 centimeters, the width is 2 centimeters, and the height is 3 centimeters. That is 10 times 2 is 20, times 3 is 60 centimeters cubed. Again, it doesn't matter which one we decide is the length, the width, and the height, because we can turn the object around and it will have the same volume. We also know, using the commutative law, that we can multiply in any order. Now let's have a look at this problem. Here we've given the area on the end. We know that the area is the base, like we did here, 4 times 2. So we can also write this rule for the volume of a prism as the area of the end, and then it's going to multiply by the height or the length that that base is stretched. In this first case, it was 3 up. In this case, you can see it's 5 long. So we can write the formula as the area of the base times the height or length of the prism. We then have 36 as the area of the end, and it's being stretched by 5 centimeters. 36 times 5 is 180 centimeters cubed. That's finding the volume of rectangular prisms.